Hello everybody. In this video we'll see that how a perceptron is trained. So first of all, the meaning of training should be clear to all of us. So let us see what we have in a perceptron. In a perceptron we have a sum function and then we have some inputs, say w1, x1, x2, x3 and so on. We can have n inputs, right? I'm just talking about a single perceptron right now. So these are our inputs, and then what the sum function does, it will just do w1 x1 plus w2 x2 plus so on wn xn, and w1 w2 w3 and wn are our weights, and then it passes through a threshold function, right? So this suppose for simplicity we take that this threshold function is a step function. It can be something else also, right? And then if this sum is greater than the threshold value, say we set the threshold value to be 0.5. If the sum is greater than the threshold value, you will get 1 as your output and otherwise you will get 0. So if your wi xi is greater than threshold, right, say this is my threshold, okay, for the step function, let me just write down as epsilon is my threshold for the step function, okay, and this will be 0 otherwise. So this is the idea. Now what is the meaning of learning? Learning means, training means, or learning means that you have to choose w1, w2, w3 and wn in such a way that you get your expected results. You see, in machine learning what we are doing, for example, if we just talk about the supervised machine learning, you already have a data. For example, you have 1000 data points for which you already know the output. You want your perceptron to learn from that data, and then for the data for which you don't have the output, then you ask your perceptron to generate the output for those data points, right? So learning means finding an optimal value of the weights, finding an optimal values of weights. That's what is learning, right? So how do we make this thing? How do we make our perceptron learn? So the idea is, suppose I have these inputs already. Suppose my training data is consisting of 100 points, okay. So I have my data point as x1, x2, xn. Let me just put 1 on the top so that I know that this is my first instance, and suppose y1 is the output which I am expecting, okay. This is the expected, like, actual output. It has to be, because I already have the data, so this should be my actual output, okay, and this is my predicted output from the perceptron, okay. So this is actual, this is predicted, right? So for the first training data, like I inserted this set of inputs and I got this as my output, but the output was supposed to be this. So it means that this much is the error, y1a minus, okay, actual data minus the predicted data. So this is my error in prediction. So what you will do, you will update your weights. For updating your weights, you have this rule. For example, w1, if you want to update w1, so this was the old value of the w1, and then you have a learning rate. How to choose learning rate, we'll see. Normally this is, say, 0.1 or 0.2, and then this your expected output, and then this is your predicted output, right, and times x1. So it means that you will actually take this thing also into consideration, because suppose this input was 0, then in the error which I am getting, I don't want to update this w1, because in the information which is right now generated, x1 did not play any role. So if x1 is 0, I do not want to update the corresponding weight. So we have this rule that this w new for any ith component would be w old plus learning rate times expected output yeah, actual output or expected output minus predicted output times your xi. So this is the rule for updating all the weights, right? So this is for I is equal to 1, 2, 3 up to n. So this you will for one particular, suppose this is my first training instance. For that I will update all the weights, and then I will go to the second instance, then again I will update all my weights, and then I'll go to the third instance and we will update all the weights, and so on, right? So you will do this thing till your training data set is used like completely, right? And sometimes there may be some conditions that we can stop earlier also if there is no further updation in your weights. So I'll give you a simple example. So this was the idea. Okay, so let us just take one example and learn how we actually are training a perceptron. So let us see that we have a perceptron which would like to learn AND gate. Okay, so suppose there is a perceptron which wants to learn AND gate. So what is an AND gate? AND gate, we know that there are two inputs, say 1 1 1 0. So let us just start with 0 0 0 0. The output is 0. Okay, this is our output. And 1 0, the output is 0. 0 1, the output is 0. And 1 1, the output is 1. So this is the we can say that this is the data available with us. This is the actual predictions we have, and we want our perceptron to learn this thing. So what a perceptron in this case is, we have two inputs, x1 and x2, right? And then we have the sum function, and then we have the step function, and suppose the threshold is 0.5, right? Okay, so now you see, so I have to start with one set of weights, so that randomly I can choose. Suppose in the beginning, to begin with, I choose my W1 and W2 both as 0.9. To begin with, I choose W1 equal to W2 is equal to 0.9, right? So this W1 is 0.9 and W2 is 0.9, right? Okay, so now I want, if these are my weights, I will see what is my like how the weight will be updated. So round one means you have the first, round one means you have the first instance. So x1 is 0, x2 is 0, right? So what will happen, the sum function would be 0.9 into 0 plus 0.9 into 0, that would be a 0. So the step function will give us a 0 value. This is what we were expecting. So therefore there is no updation. Okay, so we will not update, no updates, because this is what we were expecting. So our error is 0. And then for x1 is equal to 1 and x2 is equal to 0, that is your second instance, what will be the values? 0.9 into 1 plus 0.9 into 0, and that would be 0.9, and then threshold, okay, step function will give you 1, but we were expecting 0 output. So we have y actual minus y predicted. Actual we were expecting 0 and predicted is 1, so that's a -1. So now we have to update our weights. So W1 would be W1 old plus my learning rate. Suppose I assume my learning rate to be 0.5. Okay, let us assume this thing. So then the error, y actual minus y predicted, and then we have our x1. So this would be W old is how much? 0.9 plus 0.5 into -1 into x1 is 1. So this becomes 0.4. Now if you try to update W2, that will be W2 old plus eta y actual minus y predicted, and then you have x2. So now W2 old is 0.9 and the learning rate is 0.5, and this is -1, and x2 is 0 because we were having 0, so this would be 0.9. Now here you see, you can have an intuition for this particular term, why we are taking this particular term, because if x2 is 0, I don't know, I don't want to update my weight for a 0 input, right? Because that information I am feeding them, right? So it means that after this second instance, so we have the weights updated to 0.4 and 0.4 and 0.9, right? Now for the third, the next instance, which is x1 is 0 and x2 is 1. In that case, your w1 x1 plus w2 x2 would be, now your w1 is already updated, 0.4 into x1 is 0 plus 0.9 into x1 is 1, so that's 0.9, and again if you apply the step function, you will get 1, right? But we were expecting a 0 output, so this is y predicted and y actual was 0. Therefore, your w1 updated would be w1 old plus eta y predicted minus y actual minus y predicted, y actual minus y predicted times your x1. So this would be, because x1 is 0, so there is no change, this is 0.4. And for w2, you have old value was 0.9 and the learning rate is 0.5, and this difference is -1 and this is 1, so that becomes 0.4. So now your updated weights are 0.4 and 0.4. These are the weights right now. You can keep on training your data, right? Now you feed the next instance. So you have 1, 1. So when your x1 is 1 and x2 is 1, so now your w1 x1 plus w2 x2 would be, w1 is 0.4 and x1 is 1 plus 0.4 into 1, that would be 0.8, which again is greater than threshold. So when you apply the step function, so it would be 1. This is what we were expecting. So this is our y predicted and y actual was also 1. Therefore, they are same. So no updates in weights. Okay. So this is how we will be doing our training of the perceptrons. This is very important topic, the training of perceptron. This is a simple thing, like you just have to follow this rule that wi updated would be wi old plus the learning rate y predicted, y actual minus y predicted times your xi. So you do this for all I is equal to 1 to n and for all instances of training data, right? So this is, so here I have just taken the 4 instances of my training data. I can have further I can have more data points, and then I can train it further till I reach an optimal value of my weights. So that's an idea of the perceptron training. Thank you.